processes there, and then it outputs, and then it comes on the screen.
And next week we will look at binary. So you've got to remember that the computer can only process zeros and ones because it only has switches that are on or off. But as a human, we get confused with all the amounts of zeros and ones. So that's what we're going to look at next week. So the CPU is really important. Now, we've talked about RAM, which was random access memory, and that's the temporary data that you are currently working on, and it's volatile, which means it would get lost if the computer crashed. We're also going to talk about ROM. Now, ROM is read-only memory. Read-only memory is the opposite of volatile. It is non-volatile. And that means it doesn't get lost when the computer is switched off. And the reason for that is because it's inside the ROM that are the instructions to boot up the computer. So if you need to turn on your computer, the instructions are in ROM. And it would be pretty useless if that was temporary and got lost, wouldn't it? Because your computer simply wouldn't work. It needs to boot up the operating instructions. So the ROM is read-only memory, so you can't save to it. It just stores the instructions for you to turn on the computer. So the next one, we're going to look at main memory and permanent storage devices. Have you ever heard of the fetch, decode, execute cycle? Okay. Basically, that's what the central processing unit does. It fetches the instructions that you want to do. It decodes it by turning it into what the computer understands, and then it executes it, which means it runs it. And it does thousands and thousands and thousands of instructions per second. We're also going to look at the speed of the processor. Do you know what HZ might be? It stands for the word hertz, and it measures it by seconds. Can you imagine then what MHZ stands for?
Hertz. I'm not.
This one means 1,000, so this one is megahertz.
Oh.
And could you guess what GHZ stands for? What's bigger than thousands?
Millions.
What might this be? So this one is gigahertz. So we've got hertz, megahertz, and gigahertz. So we're going to look at the sizes of those. These are the keywords that we're just going to focus on. So if you remember last week, we talked about input, process, output. So input, remember what input was? All the data that...
So on your computer, when you click a button, it goes inside the computer.
Good. Yeah. And it's not necessarily a keyboard, is it? Do you remember we were talking about sensors?
Yeah, microphone sensors.
Perfect. Yeah, all of those things are input. So there's lots of different ways that you can put data into the computer. So then this week we're looking at the processor. So basically the processor is looking at the instruction that you have put in and then trying to match it to a program so it can do what you want it to do. And then output, do you remember we had this word last week? So what output?
So say you're speaking to your friends and you're on a mic, you're wearing a headphone, the output of the voice comes.
Good.
Also alarm.
Excellent. And excellent, well done. I was just going to say, and it's not necessarily just on the computer, is it? So you're quite right, the alarm is an output device. And then we've got these two difficult words. So volatile means the data is lost if the computer is turned off. So that data is only temporary. So you working on your computer, that's only temporary, and that's being stored in random access memory. And then non-volatile is the data held in ROM, and that is permanent. It doesn't get lost because it switches on the it boots up the operating system when you turn on the computer. So you'll remember this from the video clip that we saw. So input, we've got data going in. Output, we've got data going out. CPU, we've got the processing that's going on in between. And then we've got memory. So it's trying to find ways of saving your data somewhere. And so the storage, you can either save it on the hard disk itself on the computer, or you can save it externally to a USB drive or something like that. So you'll remember this one from the video. So we've talked about input, process, output, but there are all sorts of things that computers can be used for, and people even now have like smart clothing. So they're not just wearing their clothes, their smart clothing actually does something. So this one here, it could output lights. You could have buttons on your clothing that make your music work or something like that. So increasingly, manufacturing companies are making items that actually input and output data. Do you know what that top one is there on the top left?
The white one.
No, on the left. What's that one?
Oh,
Have you seen it when people make things from a printer?
Oh, yes, yes.
Okay, that's what this one is. So even some schools have these now, and more recently, you know, the PPE masks, the personal protective equipment that the key workers are wearing. There were lots of people who had e-printers, and they actually made some of those masks using their printers.
Yeah.
Okay, so as you are aware, the data is sent as picture elements here. So if you remember, pixel stands for picture element. And as you remembered, it's binary and it's sent as input. So as you saw in the video, that data is going into these pieces of equipment as binary. Process then is what the computer is doing with that data that it has received. So again, we've got the binary. So the data is going into the computer as binary. It works out what you need. So in this case, you've got the letter B. So the output is eventually going to be the letter B displayed on your screen. But the letter B itself to a computer means nothing.
It's 0 and 1.
That's right. So B to a computer is 01000010. It doesn't understand B. But the thing is, we understand B as humans. Okay, so this then is the output. So once the CPU, the computer, has processed that instruction, and you might want to display a B, or you might want to do something a bit more technical, like, can you see the robot arm on the bottom right?
Yes.
Yeah, so this means that these can be used by people even remotely. So there are surgeons that are actually doing operations through robotic arms. So they might be miles and miles and miles away, but they can use the computer, they can input the data, it can be processed, and then the output is actually using a robot arm inside a human body even to actually perform surgery. So it can be quite complicated. Now, memory is required to actually store the information. So we've got the input with the data going in, we've got the output with the data displayed how you want it, we've got the CPU that is processing that data, but somewhere we need some type of memory to store the information. So we talked about RAM, which is the temporary data, but we also talked about ROM, which is booting up the operating system so the computer will work. And as you rightly pointed out from the first slide, the RAM slots into the motherboard there. So the RAM is volatile, it's temporary, it's the data that you are currently working on, but ROM is read-only memory. You can't actually save to it, but it stores all the instructions to boot up your operating system so it can work. And we call this non-volatile because if the computer is switched off, it doesn't get lost. ROM looks, it's about half the length of RAM, and it almost looks like a little crawly bug, to be honest. And it's got kind of little grippy metal components there. You can see the CPU on the far side, on the other side. Can you see to the right? And there's a tiny little square thing almost towards the top.
Yes.
Yeah, that is the CPU. All these, can you see things that look like tiny little chimneys that are grey on the top and like their little black thing?
Yeah.
These are called capacitors, and these basically kind of help the electricity flow around the motherboard. And if you, I mentioned people changing their graphics card, but you could also add extra RAM to your computer. So in the same way that you can slot this one in, you can also slot in more RAM. So if you feel that you want your computer to perform better, you can actually buy a stick of RAM and put it inside your computer to improve its performance.
Yeah. I have a question.
Yeah.
You know when you said to improve, so does that mean that there's like only like two RAM sticks inside one, or?
It depends on what computer you buy, because obviously the amount of money that you are paying for your computer is dependent on what quality that computer is. So there might only be one stick of RAM in the computer that you buy, but it might be a really good price. And somebody might not want to do graphics or computer games, that they might just want to do writing some reports or something, some text, in which case they don't actually need a computer that's really high performance. They might only want to spend a certain amount of money because that's all they've got, and they don't want to play computer games. So it's all down to the quality of performance that you want and the amount of money that you are willing to pay. So you when you buy a computer, you always have to read all that small print to make sure that you're getting the performance that you actually need. Okay, so the CPU runs absolutely thousands and thousands and thousands of instructions. So we're sitting here talking about it processing instructions, but it works at a huge speed. It processes thousands of instructions. So when you actually save when you've got the data on RAM,